FG.
Oh, there's the G's. There's the B's or something.
Put function and relation in there.
I'm a little confused.
And relation is really just like it says, how do numbers relate to each other? When you think of functions and relations, you should think about the little table thing that we did with x and y values. Let me just do an easy one for you where x, let's say x is 0, y is 2, 1, 3, 2, 4, 3, 5, 4, 6, 5, 7, okay. This is a relation, and we need to talk about what specifically makes a relation. A specific type of relation is called a function. Okay, and it's nothing, it's kind of a goofy word that people use for whatever reason there. Now, a couple definitions before we talk about that. There are a bunch of ways to show this same little table here. Okay, sometimes we show this relationship in what's called a mapping. You'll remember this. We did this last year. We probably did it this year for some reason. And a mapping looks like this. You have two little ovals.
Oh, we did.
And this is like your x oval, and this is like your y oval where you have 0, 2, 0, 1, 2, 4, 5. And then over here you have the 2, 3, 4, 6, and 7. And then there's arrows that shoot across like this.
Oh,
Remember
yeah,
that?
you can't go to the one number or something.
Well, we're getting to that. Thanks for remembering part of that. Okay.
Yeah.
Okay. Now, here is some other definition stuff there. The x values, children, the x values here and here are called the domain numbers. Domain. And there was a way to remember this, but I don't remember what it was. Anybody know what the y numbers were called?
Do not made.
Function.
The donuts, no.
Dominant.
Those were called the range numbers. I guess I shouldn't use words. Okay. Now a third way that you can show this whole relationship thing is by using ordered pairs. In other words, I can do this whole thing and this whole thing by doing this. 0, 2, and then 1, 3, and 2, 4, and 4, 6, and 5, 7. This, all the same thing, just different ways to show it. These are called ordered pairs. Because remember, in ordered pairs, the first number is always the x number. This is xy, this is xy, this is xy, xy, xy. For what the book will give you is they will give you a group of numbers like this. 3, 8, 7, 9, 4, 8, 6, 1. I am making this up in my head. If I gave you this group of ordered pairs and asked you to give me the domain numbers, domain would equal, and then you put this little my favorite thing to make because it's going to be a set of numbers. What is the domain of these ordered pairs? It's just the x numbers in all of them. So it would be 3, 7, 4, and 6. It's just the first numbers because that's the x, that's the first part there. And the range would be all of the y numbers, which are the second numbers, 8, 9, oops, I already have an 8, so I don't need that again, and a 1. Now the question we have is what makes a relation a function? Because functions are a special type of relation. You may remember what it is, it's an interesting sort of thing. Morgan alluded to it.
Oh, where you go to put the arrows and
Something to do with the arrow things.
Can't fix you, mister.
Something to do with the arrow things. I remember what it was.
Is this one of your things?
Oh, the study cabinet. I have no idea what that is.
I thought maybe that was your one subscription, the other subscription, no?
Oh, look, but that thing was called,
Well, if you don't you would recognize it.
I don't recognize that one.
Alright. It was November.
Somebody got an answer for me. Caroline says,
The domain can only get mapped to one member of the range.
right, write that down. If you don't have it somewhere, I wish I left myself enough space for it. Let's do it right here. Whoa. And this is what it is. Jot this down. Each domain, I guess each element or whatever, each domain number can only go to one range number. That is a function in a proverbial nutshell. I'll let you write that down, then we'll talk about that. I got that because I got to zoom out. So the question you ask yourself, you look simply and only at the domain numbers, and off of each domain number, there can only be one arrow coming off of each one. Is there only one coming off of each one?
yes.
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 Okay. So this is, yes, a function because there's only one. Now, please understand this because this is where people get confused. You can have the same number or two different domains going to the same range. In other words, I could have this. Let's see, let me erase something here. Oh, too big. Let's go with the smaller eraser, shall we? I could have this. Let me erase this. This could happen and still be a function.
It's permanent.
Maybe we push harder.
If I push these.
Yeah.
Let's just pretend that's good. In other words, this 1 could go to 2 as well. This is still a function because the rule is still okay. Because each one of these only has one arrow going off it. They could all go to the same number in the range. Because it still works with this rule, only one thing coming off of each one. What can't happen is this. I can't have 0 be paired or mapped to both 2 and 4. If you saw 2 lines coming off of that 0, this is no longer a function. Okay? And that gets people a little confused because it's hard for them to think one way and not the other way. You can have this, 2 different ones going to the same one, but you can't have the same one going to 2 different things from the range, from the domain side.
0 can't go forward.
0 cannot go to 4 and go to 2. It can only go to one thing and one thing only. Okay?
It can either go to 2 or 4.
We actually are going to stop.